Alright guys, welcome to graphing and solving quadratic inequalities. We've spoken and talked a lot about graphing quadratic equations and solving them and finding, the x-intercepts, the roots, the zeros. But we're going to take that a step further. We're going to talk about inequalities. So the big thing you got to realize is that there's going to be more than one solution here for these inequalities. Okay, and we're going to follow these steps for graphing a quadratic inequality. So that's one of our first objectives, graphing quadratic inequalities. First, you're going to graph the function using a previously learned technique. So whether I give you factored form, vertex form, or standard form, graph that function based on what you've learned. Two notes to add: if you have a less than or greater than sign, use a dashed line. If you have a less than or equal to sign or greater than or equal to sign, use a solid line when you're connecting that smooth curve. Okay, so that's really important. Step number 2, test a point. You got to pick a point that's not on your quadratic line, quadratic curve, and test it. Test xy not on f of x and determine if xy is a solution, to determine if that point makes the inequality true. If it does, and this is how we shade, we shade inside f of x if xy is a solution, and outside if xy is not a solution. And you got to be really careful with that. So if I test a point outside and it makes my inequality true, shade outside. Okay, this is kind of really just talking about the opposite. If you pick a point inside and it doesn't work, then you shade outside. Vice versa, if you pick a point outside and you test it and it doesn't work, you shade inside. All right, so we're going to look at that shading, and that's really kind of the most important piece, step 2 and 3 here, making sure you have a correct dotted line and shading in the right area. Okay. So in this first example, I've already gone ahead and graphed the quadratic, and you can see the work here on the left. Okay, the line is going to be dashed because of that inequality, greater than, and that's x squared plus 4x plus 2. We're going to graph that. Y is greater than x squared plus 4x plus 2. So really you treat it as this is an equal sign for now. Number 1, I put the line is dashed. Okay, that's the first thing I notice. Okay, and then I'm going to go ahead and find the axis of symmetry by plugging in my b value, which is 4, so you have negative 4 over 2, and that equals negative 2. So I have that dashed line if I want to draw that in at negative 2. And the vertex, I plug negative 2 back into the original function, and I get negative 2. So the vertex is negative 2, 2, and I go ahead and create my parabola. I pick a couple other points. Step number 2 here down, you got to test. I picked 0, 0, and 0, 0 is always a really good point to pick. If it doesn't hit your function, it's very easy. So test 0, 0. So is 0 greater than 0 plus 0 plus 2? So is 0 greater than 2? That answer is no. So I've picked this point here to test, and I got a no. On the outside of the parabola, I got a no. So that means I fail inside. And I've shaded that in blue. And that's our objective. That's how you graph a quadratic inequality. Not much different. Make sure the line is dashed in this case. All right, and I did show some scratch work here. You should know how to find the vertex. The only thing new is kind of just really right here, testing that point. All right, in example 2, graph y is greater than negative x squared plus 4x minus 3. So very similar to the last problem, and I wanted to make sure I kept examples where the line isn't one complete line. These are all dashed lines, okay? Because that's one mistake we can make a lot when we're graphing quadratic inequalities. So I'm going to graph this function. I know that a is negative, so I know it should open down, and it's going to be a dashed line. So I just made a couple notes to myself. Again, find the axis of symmetry. I went ahead and did that, and I plotted my quadratic. It's a dotted line because of that inequality. So there's the quadratic drawn in, opening down. The really important thing here is let's test this. Again, look, I picked 0, 0 because that's not on my parabola. 0, 0 is right here. So I test that point, and I got something that's true. 0 is greater than negative 3 when I plug 0 in for both x and y. That is a true statement. So I had a point on the outside, and I got a true statement, so I shade along the outside of the parabola. Okay? Lastly, we're going to solve a quadratic inequality algebraically. Okay, now this is a little bit different than solving quadratic equations. With equations, we could have up to 2 real solutions. But this is going to be a little different, but we're going to use some of the same techniques. So solve x squared minus 2x is greater than 15. So I rewrite setting one side equals 0. Okay, so I actually put x squared minus 2x equals 15. I'm actually going to treat this inequality at first like an equation. So I use the equal sign, and then I set that side equal to 0. We're solving a quadratic. You definitely want one side to be equal to 0. And then I'm going to factor if possible, or use some other technique that we've learned for solving quadratics. Quadratic formula, completing the square, factoring. The other one was square root property. So I factored this guy. 2 numbers that multiply to be negative 15 add to be negative 2 are negative 5 and 3. So I went ahead and factored. I know that x equals 5 or x equals negative 3. These are what we're going to call these critical values. Okay. So now, just like we did when we solved even compound or absolute value inequalities, we put a number line down, and I have open circles at negative 3 and 5 because of that inequality right there. So open circles. And now I have to test points. I have to see where this shading is going to be. This is an inequality. So there's not going to be just one ordered pair that's an answer. So at 5, I can't use 5. I picked 6 and plugged that in. 6 squared minus 2 times 6. Is that greater than 15? It is. So I shade to the right. So when I pick my test point, I plug that test point back into the inequality. Here I picked negative 4. Because that's to the left of my critical value, plugged it in, and I got something that's true also, so I shade to the left. You shade to where your solutions are. So that is the solution set. You could say we have x equals 5 or x equals negative 3. That's for the equation. But what you could really say is x now would be greater than 5, and x is less than negative 3. That would be the solution set based on that inequality. So those are still critical values when you factor, but it's not equals this. X is not equal to 5 or x equals negative 3. They have to include that inequality. And to figure out what the solution is, you've got to put your critical values on that number line and test points. Just like we did from the graph. Test points. Where do we shade? Same thing here when we solve a quadratic inequality algebraically. Figure out where to test the points. So that's quadratic inequalities, graphing and solving algebraically. If you guys have any questions or comments, you can put them below, or you can email me at nicholas.bennett@dc.gov. We'll see you next time.